Let's go through Liquid 156 binary tree upside down. For this, give us a binary tree and let's uh, get it upside down. But for this binary tree, you say that so there is so this binary tree for each left node child it has a right child, and there is the rule is that we need to original left child becomes the new root, and the original root becomes the new right child, and the original right child becomes the new left child. So it will um, make something like this, right? So you say that for each right node, there must have a left node, right? And also say that right node has no children. Um, so actually, this condition, the right node has no children, simplify our question, right? Because in the end, what the tree will be like in a format like this. Just have one node on its left. So we don't need to treat this part, but we should also be able to treat this part if we want to. Um, so if so because we don't need to treat these nodes, right? So this question actually it is just that we need to go through from the root to the leftmost, right? Because this tree is kind of very it simplify our question. So we just need to from this kind of route to go through its leftmost and then redo the connect. So this one it is actually we need to what we'll look at the what we are doing. Let's see. We need to reverse this link, right? Reverse this link, and also for every part, for example, the well, see, this is pre, right? This is current. Every pre is right. We should connect to here, right? As it's left, right? So what we do is that so there are two ways to do this. One is using recursive code, right? As long as we already done for its left child, then we reconnect. Another way we do it, it is just like a reverse linked list, right? Because we just need to go through this kind of path, so we can use a pre in the current, right? And a reverse linked list um, has a temp, right? And a current move pointing to pre. But comparing to the reverse linked list is that we need to have the pre's right to connect to current left. Current left will connect to pre the right. This part also need to reconnect. So let's write both way. The first solution is that let's do the recursive way. So mm, we can write if root equals null, right? Mm, And we'll see if this is a leaf, right? We can also root dot leaf left equals null, and root dot right equals null, right? We just return root. Otherwise, we're going to have a tree node result equals upside down tree root dot left, right? And what we need is root dot left equals root dot right. And we need to have a root dot left dot right equals root. And we also need to have the root dot right equals null, right? And have root dot left equals null. And in the end, just return result. So this is a recursive way to do this. For the recursive way, it will be O n time complexity, but the space will be OH because it has the stack, the functional recursive stack used, right? So with this question, actually, the beta solution is use iterative way that we just do the reverse linked list for this path, right? Reverse linked list for this path. But the thing is that beyond the reverse linked list, we need to reconnect this part as reconnect the previous this is previous node's right child, right, to current left as current left, right? So let's just also write the iterative way of this. So we'll say if root equals null, and just return null. And we need a tree node for current equals root and pre equals null, right? And we can have to connect equals null, right? This is just a pre right, but for this null, we write this outside so that we don't need to check whether the pre is null or not, right? Because this is null, to connect is also null, right? Otherwise, if we put this inside while loop, we need to check whether pre is null or not. So what we will write is y current done equal to null. Okay, we'll have tree node next equals current dot left, right? So remember the 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 reverse linked list. What we need to write the reverse linked list is current dot next equals pre, right? And pre equals current, and the current equals next. And in the end, return pre, right? So this is a returning list. But but for this one, there's an extra step that for the previous write, or we call connect to connect, right? So we'll have current dot left equals to connect. Um, if you write, for example, you create a variable here, right? We node to connect, so whatever to connect. You need to check if pre equals null or not, right? Otherwise, so you'll say you need another if statement. So put this variable here will be better. So write current dot left equals to connect. And then after that, we'll have to connect equals current dot right, right? Because pre equals current, right? We can also put this one here to be logical more clear, right? So let's see. So this will be the while loop way current, but not current dot next is current dot right. Let's current dot right already changed to pre. Let's we have to put this one here because this one already changed to pre, right? So this can be put here. This to connect is actually the place right can be used for the next iteration for while loop. So it will be O(n) time complexity with constant space space plex constant space complexity, and we also need a Python code for this. So we'll say if not root, let's return none, and we'll have current free to connect equals root none none, right? So what we do is the while current, then we need next node called next equals current dot left, and current dot left equals to connect. Let's say that to connect equals current dot right, right, and then we reconnect current dot right equals pre, and pre equals current, and we'll have current equals next. In the end, just return free.